Hello everybody, welcome back to another AP Calculus ABBC video. This is Unit 6, Lesson 4, Accumulation Functions. So if you have a function as the integral from a to b where your upper limit is a function and your lower limit is a constant, then you can use the fundamental theorem of calculus. So let's check that out. Number 1. F of x is equal to the integral from 2 to x of t cubed dt. Okay, so we have to find f prime. So f prime of x. So derivative and integral. So if you're finding the derivative of an integral, then you're going to substitute your upper limit, your function, into the integrand, right, which is everything inside the integral. And then you're gonna do chain rule if it applies, right? So, okay, so f prime of x is equal to, so if you do d dx, that gets rid of the integral, and you plug in x into t, and you get x cubed. If you do chain rule, well, the derivative of x is just 1, right? So f prime of x is x cubed. So it's a pretty straightforward concept. It can get a little bit tricky with some of them, but overall it's not too bad. Okay. Number 2, f of x equals integral from 0 to x of 5 dt. So f prime of x. So if you find a derivative on both sides, you get f prime of x equals. Derivative in this integral cancel out. So this x cannot go anywhere, right? This is 5, so it stays at 5. Okay, next we have f of x equals integral from -1 to x of 4t minus t squared parentheses dt. Okay, so again we want to check for the format. We have a constant bottom function at the top, so we can use the fundamental theorem of calculus. So f prime of x, so the derivative gets rid of the integral, and you plug in x into t. So 4x minus x squared. That is your f prime of x. 4. F of x equals integral from pi to x of cosine t. So pi is a constant, x is a function. So we can use FTC to find our answer. So f prime of x, derivative times integral, derivative of the integral is just going to get rid of the integral. So we just get cosine x, right? And the x goes into t. Okay. 5. F of x equals x squared, integral from 1 to x squared of t cubed times dt. So f prime of x equals derivative of integral cancels out. So you're left with x squared to the third power. Now, x squared has a chain rule. So what's the derivative of x squared? 2x. X squared to the third power is x to the 6. So x to the 6 times 2x, and that is going to give us 2x to the 7th. Right, x to the 6 times x to the 1 is x to the 7th times 2 is 2x to the 7th. Okay. Next, we have f of x equals integral from pi to x squared of sine t dt. So f prime of x, derivative and integral cancel out. So we get sine of x squared. And don't forget chain rule. And that is your answer. Alright, so find the derivative of both sides. F prime of x equals derivative and integral cancel out. So we get left with 1 over sine x times chain rule, which is cosine x. F of x equals that, so derivative of f is going to be equal to 3 square root of x squared times chain rule 2x. F of x equals integral from 0 to 3x of 2t dt. So f prime equals 2 times 3x times 3. Now that is very sloppy, so I'm going to erase. 2 times 3x. Oh, I did it again. Well, you know that's 3x, so there. Okay. Okay. Derivative of both sides. D dx and integral cancel out, so tan x squared. Derivative of tan is secant squared x. Always remember chain rule. F prime of x equals d dx and integral cancel out, so tan of x squared times chain rule 2x. Here we have f prime of x, and g of x is still a function, right? So we plug in g of x into t, then chain rule, which is the derivative of g. Okay, derivative of f is f prime. Derivative and integral cancel out, so f of 2x times chain rule times 2. Here we have function both in the upper limit and in the lower limit, so we need to do what is similar to quotient rule, but no division, right? So we're gonna take this minus that, right? So what I mean by that is f prime of x equals 4 times x plus 2 plus 1 minus 4x plus 1. So we have our upper limit minus our lower limit after plugging in. So this becomes 4x plus 9. And this is just going to remain 4x plus 1. 4x plus 9 minus 4x minus 1. We get 4x minus 4x and 9 minus 1, which is 8. Here we have, again, similar thing. F prime of x equals 3x minus 1 minus 3 negative x squared, right, minus 1. Sorry. Okay, and then don't forget the chain rule. In the chain rule, you're going to multiply that by all of this, right? Not just in here, all of this. So simplify 3x minus 1 minus, okay, minus is plus, so plus 3x squared, minus again plus, and then keep the parentheses there, right? Because we still have to multiply by negative 2x, so 3x minus 1. 3x squared times negative 2 is negative 6x cubed. 1 times negative 2x is negative 2x. 3x minus 2x is x minus 1. And then there we go. So, and then that's plus. Okay. I believe we have 2 more. So, f prime of x equals, and then upper minus lower. So, upper minus lower. So this is just going to be, and then don't forget times -1. This keeps getting sloppier and sloppier. Okay, times -1. Why is it times -1? We have to do chain rule, right? Derivative of negative x is -1. So x cubed minus becomes positive times negative, so that stays negative. We get 0. For our last one, we have f prime of x equals 3x squared times 3 minus 2x squared times 2. Okay, so apply the square, get 9x squared. Apply the square here, we get 4x squared. 3 times 9 is 27, x squared. 2 times 4 is 8, so negative 8x squared. 27 minus 8 is 19x squared. And there we have it. Alright, test prep. Let g of x equal derivative of dx, derivative with respect to x of, or just times the integral from 0 to x of square root of t squared plus 9 times dt. Alright, what is g of -4? So remember that if you have a constant as your lower limit and function upper limit as long as it's respect to x, we can use the fundamental theorem of calculus. So g of x becomes square root of x squared plus 9, chain rule times 1, right? So g of -4 equals -4 squared plus 9, 16 plus 9 equals 5, right? So pretty straightforward question. Answer is going to be 5. Okay. The graph of a function f on the closed interval 0 to 6 is shown above. Let h of x equal integral from 0 to x f of t dt for 0 to 6. Find h prime of 3. So h prime of x equals f of x. So h prime of 3 equals f of 3. And so f of 3 right here, our graph is f, right? So f of 3 is clearly 0. Apologize for that. And our last question here. So the figure above shows the region A, which is bounded by the x and y axes. The graph of f of x equals 1 minus cosine x over x for x is greater than 0, and the vertical line x equals b. B increases at a rate of pi over 2 units per second. How fast is the area of region A increasing when b equals -3? Okay, so let's write what we know. B equals pi over 3, and it says b increases at a rate of pi over 2 units per second, and this is b equals pi over 3. Just that's fine like that. And it's asking how fast is the area increasing. So dA dt is what we're solving for. Okay, if you remember, an integral is the area under the curve. So the area under the curve A is going to be the integral from 0 to this point right here. It's from 0 to b. And our function of this graph is given as 1 minus cosine x over x. So and obviously with respect to x. This question is asking us how fast is the area of region A increasing? So we're trying to solve for dA dt. According to our fundamental theorem of calculus, we can find the derivative of both sides and the integral will get eliminated. So we are now left with 1 minus cosine b over b. And remember that we have to do chain rule. So times dB dt. Okay. So b is pi over 3. So what's cosine pi over 3? Cosine pi over 3. Use our unit circle knowledge, 643. So it should be 1/2, if I'm not mistaken. So 1/2. So 1 minus 1/2 over pi over 3. dB dt, that's given to us in the problem, right? That's given to us right here. B increases at a rate of pi over 2. So if we simplify, we get 1 over 2 times 3 over pi times pi over 2. Pi cancel out. 3 over 2 times 2 is 3 over 4. So we just used what the problem gave us, dB dt as pi over 2, b equals pi over 3. Again, the area under the curve is the integral, and we're just using the fundamental theorem of calculus to solve this problem. So I hope this was informative. Any questions, as always, please let me know, and I'll see you for the next lesson. Take care.